morning, students. Our next property based on adjoint of the matrix. Okay. Determinant of adjoint of A is equal to det A whole power n minus 1, where n is order of the matrix A. Here you understand, whenever they given the matrix A and he is asking to find out the determinant of adjoint of A without finding adjoint of A. Adjoint of A means what? Transposition of the cofactor matrix. So we have to find out cofactors and go for transposition. So that is lengthy method. So instead of that one, if you do this one, det A, find out det A, take a power n minus 1. That gives a determinant of adjoint of A. Proof of this one is, we know the previous property. What is that? A into adjoint of A is equal to det A into I. Okay. A into adjoint of A is equal to det A into I. Apply determinant on both sides because of we want determinant of adjoint of A. So to get determinant of adjoint of A, both sides apply determinant. So that means determinant of A into adjoint of A is equal to determinant of det A into I. You understand, determinant of any matrix is a scalar, that is nothing but a constant. Okay, so you understand here, this is a matrix A, adjoint of A also one matrix. Okay, so determinant of A into B is nothing but determinant of A into determinant of B. B means adjoint of A. So determinant of A into determinant of adjoint of A is equal to, this is nothing but some K. It is nothing but I. Actually we have the formula, determinant of Ka is equal to K power n into determinant of A. K power n into determinant of A. Actually yesterday I gave one property, determinant of, that means adjoint of Ka is equal to, not determinant, adjoint of Ka is equal to, it is determinant of Ka, adjoint of Ka is equal to K power n minus 1 into adjoint of A. Don't get confusion. If it is determinant, K power n you will get. If it is adjoint of Ka, K power n minus 1 into adjoint of A. See, this is the property where it is, yes, adjoint of Ka is equal to K power n minus 1 into adjoint of A. Don't get confusion for these two formulas. Okay, now this it is a scalar. Okay, determinant of A is nothing but a scalar, means constant, divide, transpose to this side. So determinant of adjoint of A is equal to det A whole power n into determinant of A, because of it is some K. So K power n into det I. Already you know determinant of identity matrix is equal to 1. So determinant of A power n into 1, this det A transpose this side, so it by det A. So A power n by A power n minus 1. That means det A whole power n minus 1. So this is the answer. Very, very important. Determinant of adjoint of A is equal to determinant of A power n minus 1. Next one. If order of A is 3 by 3, det A is equal to minus 2. It is one of the problem. Then find determinant of adjoint of A. It is symbol for determinant. Determinant of adjoint of A. See here, what is the given? Order of A is 3 by, that means n is equal to 3 they given, and det A also they given minus 2. So what is the formula? Determinant of adjoint of A is equal to det A whole power n minus 1. So determinant of adjoint of A is equal to det A means here minus 2 they given, whole power n minus 1. N means here 3 by 3 order. Okay, 3, n is equal to 3. So minus 2 whole power 3 minus 1, that is minus 2 whole square. So negative power even number gives positive, and 2 square is equal to 4. That is the answer. Next question. If order of A is 3 by 3 such that determinant of adjoint of A is equal to 16, then det A is. See here, we know that determinant of adjoint of A is equal to det A whole power n minus 1. That means 16 is equal to, if you write a determinant of adjoint of A, so we want in terms of det A. So this determinant of adjoint of A you can write as det A whole power n minus 1. That means det A whole power 3 minus 1, because n is equal to 3. So det A whole power 3 minus 1 is equal to 16. So 16 is equal to det A whole square. So det A is equal to root 16. So det A is equal to plus or minus 4. Actually should not write root 16. This is a plus or minus root 16. So root 16 value becomes to 4. So det A is equal to plus or minus 4. Okay. Actually we have the formula, if x square is equal to a, x is equal to plus or minus root a. This is the formula. So it is some x square is equal to 16 means x is equal to plus or minus root 16. Root 16 value is 4 only. Next problem. If order of A is 3 by 3 and A into adjoint of A is equal to 4 0 0 0 4 0 0 0 4, then determinant of adjoint of 2A. Here two concepts we have to use. First formula, adjoint of some Ka. It is nothing but K power n minus 1 into adjoint of A. Okay, here n is 3 by 3. N is equal to 3. That means. So, and they given A into adjoint of A value, this one. So, A into adjoint of A is nothing but det A into I. Okay. So, det A value, det A into I, they given 4 0 0 0 4 0 0 0 4. So, det A into I means if we take 4 common from this matrix, 4 into 1 0 0 0 1 0 0 0 1. So, this is nothing but 4 into I. So, det A into I is nothing but 4 into I. So, that A is equal to 4 we have from this one. Okay, very clear. So, that A is equal to 4 we have. Now, we have to find out determinant of adjoint of 2A. Determinant of adjoint of 2A is nothing but 2 power n minus 1 into adjoint of A. Okay. Or in other words, we can write one thing. This 2A also one matrix. Let us consider this is sum B. Okay, this is one more method without confusion. Let us consider this 2A is sum B. Adjoint of B is equal to, okay, determinant of adjoint of B is equal to determinant of B whole power n minus 1. Okay, determinant of B whole power n minus 1. In the place of B we are 2A. So determinant of 2A whole power n minus 1. See here, determinant of 2A. Actually, what is the formula? Det Ka. Determinant of Ka is equal to K power n into det A. Here n means order 3. Okay, that means 2 cube into determinant of A whole power n minus 1. N is equal to 3. 3 minus 1 and 2. That means. So, this is nothing but 2 cube whole square into det A whole square. So, 2 cube whole square means 2 power 6. That is 64. Det A whole square. Det A value you got here 4. That is 4 square. So, 64 into 64. Sorry. This is 4 square means 16. So, 64 into 16. That is the answer. Once you simplify, that value becomes to 1024. Okay. Next question. Similarly, we have one more property. Here what is determinant of adjoint of A is equal to det A whole power n minus 1. Now, determinant of adjoint of A. Determinant of adjoint of A becomes to det A whole power n minus 1 whole square. If it is a determinant of adjoint of A, det A whole power n minus 1 whole square. Determinant of adjoint of A is equal to det A whole power n minus 1 whole cube. If it is 2 adjoints are there, n minus 1 whole square. 3 adjoints are there, n minus 1 whole cube. If it is r times are there, determinant of A whole power n minus 1 whole power r. Okay. So, this is the formula. Next one. Adjoint of AB is equal to adjoint of B into adjoint of A. Okay. Reverse. Same like AB whole transpose, B transpose into A transpose, no? Same like adjoint of AB is nothing but adjoint of B into adjoint of A. First B matrix, after that A matrix. Next, similarly, adjoint of ABC, adjoint of C, adjoint of B, adjoint of A. Okay, and so on. It is any number of matrices we can take. Next one. Adjoint of A inverse is equal to. Actually, these proofs once if you take matrices sum two matrices A and B, which has multiplication is possible, and go for adjoint of AB, and individually you go for adjoint of B and adjoint of A, you can show this one. Okay, by taking different two matrices. See, this one is adjoint of A inverse. Inverse is equal to, actually inverse matrix we will discuss in next, okay, continuation, uh, that is concept. Now adjoint of A inverse is equal to, once you remember, adjoint of a whole inverse. Adjoint of A inverse is equal to adjoint of a whole inverse. Proof. So A inverse, okay, leave it here. Leave it. This one we will explain later after completion of inverse, because of so many concepts are there involving in this formula. So first we have to find out what is the inverse matrix. After that we will discuss about this one. Okay. So now go to inverse of matrix. Okay. Inverse of matrix. A square matrix A is said to be invertible if there exists a square matrix of same order B such that AB is equal to BA is equal to I, then inverse of A is denoted by A inverse. Okay, once you remember, a square matrix A is said to be invertible if there exists a square matrix of same order B such that AB is equal to BA is equal to I, then inverse of A is denoted by A inverse, and that inverse of A is nothing but B. Okay, so that is nothing but B is equal to A inverse. You can say directly, that is here. If AB is equal to BA is equal to I, then A inverse is equal to B. So that means, what can you say? Here B is nothing but A inverse only. So A into A inverse is equal to A inverse into A is equal to I. This is also one of the property. Just remember. Always A into A inverse is equal to A inverse into A is equal to I. Okay. Now continuation. Since A into adjoint of A is equal to that A into I, we proved. Similarly, adjoint of A into A, if you take same, you get that A into I only. So A into adjoint of A is equal to adjoint of A into A is equal to that A into I. So this that A, if you transpose this side, that means in other words, yes, if det A you divide entire this equation, if you divide with det A on both sides, so this is not adjoint, this is det A, okay, on both sides, then and you give that det A to denominator of adjoint of A, then A into adjoint of A by det A is equal to adjoint of A by det A into A is equal to det A into I by det A. So now this det A get cancelled. Yes. See here, A into adjoint of A by det A is equal to adjoint of A by det A into A is equal to what you get? I. Same. A into B is equal to A into B is equal to B into A is equal to I. Then B is called inverse of A and it is denoted by A inverse. That means A into A inverse is equal to A inverse into A is equal to I. In the same way, in the place of B, what is the matrix here? Adjoint of A by det A. It is also a matrix. Det A is the constant. Adjoint of A is a matrix. A matrix, if you divide with a constant, okay, that gives again constant, the matrix only. That is again a matrix. So A into, in the place of B, adjoint of A by det A. So what can you say here? This adjoint A by det A is nothing but that is nothing but A inverse. If you follow this one. So A inverse is equal to, what can you say? Adjoint of A by det A. This is very, very important. Okay. So now, therefore, A inverse exists if and only if det A is not equal to 0. Why? If A inverse exists means this denominator should not be 0. Denominator should not be 0 means det A is not equal to 0. If det A is equal to 0, then that matrix A is called singular matrix. If det A is not equal to 0, that is a non-singular matrix. So what can you say? When A inverse exists, if A is non-singular matrix. We should remember, very, very important. Okay. One example you take. Actually, whenever, if A is a 2 by 2 matrix, if A is 2 by 2 matrix, let us consider A, B, C, D. Then adjoint of A is nothing but, once you remember, this is very, very shortcut, important, no need to do. Okay. So adjoint of A. Generally, adjoint of A is nothing but for 2 by 2 matrix. Just to interchange these two principal diagonal elements, interchange. Here D you write, here you write. And write as it is BC, same positions with opposite sign, minus B minus C. Why we are getting? Adjoint of A is nothing but transposition of its cofactor matrix. So, whenever A, B, C, D are there, so if it is 2 by 2 matrix, the cofactor of A is nothing but D. Why? Because so it is for A you get plus, and the minor of A is nothing but leave the row and column passing through A, then you get only single element, that is only its minor. Okay, this is for plus, this is for minus. So for cofactor of B, minus C you get. So here you get here D you get, here minus C you get. Okay, next cofactor of C is here it is plus minus. So here you get, this is nothing but 2 1 position, it is also minus. So cofactor of C is nothing but leave the row and column, and you get a minus B. So here you get a minus B corresponding cofactor. And for D it is plus, you get leave the row and column passing through D, then you have only A. The corresponding cofactor of D is nothing but A. So then its cofactor matrix is nothing but very clearly D minus C minus B A. So transposition is nothing but, so D minus C we should write in the column, and here what you have, minus BA, so minus BA right here. Okay, so directly just by heart method, so AD interchange, and for BC you just write opposite signs. So now what is A inverse? 1 by det A into 1 by det A into adjoint of A. What is det A here? AD minus BC. Det A is nothing but 2 by 2 matrix, AD minus BC into adjoint of A, D minus B minus C A. So directly we can write this formula for A inverse whenever 2 by 2 matrix. See one example. If A is equal to 1 minus 3, 3, 7, find adjoint of A. What is adjoint of A? 1, 7 interchange, and for minus 3 you give plus 3, this plus 3 you give minus 3. Then what is A inverse? 1 by det A. Det A means 1 7s are 7, minus of 3 into minus 3, that means minus 9. So 7 minus of minus 9, 7 plus 9. 7 plus 9 is nothing but 16 into adjoint of A, 7 3 minus 3 1. So just multiply 1 by 16 inside. So 7 by 16, 3 by 16, minus 3 by 16, 1 by 16. That is the A inverse. So for 3 by 3 matrix we will discuss in next video.